Hi, so here's a redox equation balancing that we can work through together. It's 2017 question 1 part F, which was a question that lots of students struggled with. So let's just read the question together. We've got aqueous solutions of potassium manganate 6, okay, and in an earlier part of the question we worked out the formula of manganate 6. So it's K2MnO4, right? So the anion is MnO4 2 minus. As you can see, the potassium, we've got 2 potassiums each, which is 1 plus. Okay, so that's the formula of potassium manganate 6, right? And okay, they're only stable at high pH, which is alkali, of course. So at neutral pH, the substance disproportionates. And the reduction product is manganate 4 oxide. Okay, so let's just write down the formula of manganate 4. So that's going to be MnO2. So now we have to write a balanced equation for this disproportionation reaction. Okay, so we remember that disproportionation reaction means that we get something is being both reduced and oxidized. Right, so one component of the reactant is being reduced, and at the same time, the same component is being oxidized. All right, so it can't be oxygen, right? That's disproportionate. It can't be potassium. That's always +1, right? So it must be manganese that is disproportionating. All right. So and these reactions are redox reactions, ionic equations. And so potassium is a spectator ion, so we're going to just ignore potassium. So it's all about the manganese. So let's write down our manganate 6 ion, right? So MnO4 2 minus is our manganate 6 ion, right? And let's think about when that reduces. When that reduces, we're going to get this, we're told in the question, we're going to get manganate 4, or oxide. Okay, so there's MnO2, all right, and because it's a disproportionation reaction, we know that the same species must oxidize, all right, and if manganate is 6, oxidation state of 6 here, what ion is manganate more than 6? Well, there's only manganate 7, all right, and we've come across it before. So manganate 7 is MnO4 1 minus, where the oxidation state of manganese is 7. Okay, so that's the main product of the oxidation reaction, all right, manganese 7, and that's the main product of the reduction reaction. So now we're going to write down the two half equations. So why don't we start with the reduction equation, reduction half equation. So as we can see, we've got manganate 6, right, and we're going to leave some space because we have to add our hydrogens and electrons and stuff, and we're going to write down. We know that it reduces to manganate 4, like so. Okay, so first step is to balance our non-oxygen hydrogen atoms, which is magnesium with manganese, and we've got 1 of each, so that's already fine. Second step, balance oxygens. We've got 4 on the left, 2 on the right. So let's put 2 waters on the right hand side. Next step, balance hydrogens. Well, we've got 4 on the right and we've got none on the left. So let's have 4H plus there. And now lastly, we balance charges. And so you can see we're going to have to put 2 electrons in here to make left hand side neutral, seeing as right hand side is already neutral. Okay, and there we have a half equation for the reduction reaction. Let's do similar exercise for the oxidation half equation, and we know that disproportionation reaction, we're starting off with the same manganate 6, but this time we make manganate 7 with it. All right, so MnO4 1 minus. Okay, so manganese is balanced already, oxygen is balanced already, and so we just need to balance our charges. All right, so we're going to have to put an electron in here. All right, so that was quite easy. That's our half equation done already. Now when we want to add the two half equations together, we have to make sure that the electrons are going to cancel. So we're going to have to multiply the oxidation reaction by 2. So we would have 2 manganese 6, we'd have 2 manganese 7, and we have 2 electrons. Okay, so now we're going to just add them together. So we've got 2 manganese 6s on the oxidation plus the manganese 6 on the reduction, right? So we've got 3 altogether. And we've still got 4 hydrogens so far. Our electrons have cancelled out. And on the right-hand side, we've got our manganese oxide, and we've got 2 manganese 7s, and we've got 2 waters. Okay, so that's not bad, but it would be a mistake to stop there because we have to remember that it's in alkali conditions. All right, so we have the final step, which is to add hydroxides. All right, and so we're going to add 4 hydroxides to each side because we've got 4 hydrogens to neutralize. Okay, so it's a balanced equation, so we have to do the same to both sides. Here, so this, let me just change color. This then becomes 4H2O. All right, and therefore we've got some cancelling to do. So those 2 waters can cancel, and those 2 are going to cancel with 2 of those 4 waters on the left-hand side. And we've just about finished, so we can just write out the final equation, which is 3 manganese 6 plus 2 remaining waters gives us manganese oxide, 2 manganese 7s, and 4 hydroxides. And there you have it. Hope that's helped. Sorry, just looking back at the question, let me improve something that I said on the previous slide. So it's not happening at alkali conditions, it's happening at neutral pHs, which means the left-hand side of our equation can't have hydrogen ions in it, it has to be neutral. Right, so that's why we added our 4 hydroxides to both sides, so that our left-hand side could be neutral.